In this video, we're going to be looking at the Resione F39 flexible resin. Unlike most typical 3D printing resins, the F39 material has a low Shore value and a lot of flexibility. The Resione F39 flexible resin ships in a bottle that looks like pretty much all other resin bottles, and before we dive into how it performed, I want to take a minute to talk about that word flexible. Flexibility can be used to describe a few different things, but in the 3D printing space, we typically focus on shore hardness. According to the spec sheet provided by Resione, the shore hardness of the F39 material is somewhere around 60 to 70 on the Shore A scale. For context, a Shore A value of 60 to 70 is somewhere around the hardness of a car tire tread. It's a little bit softer than a shoe heel, but harder than a pencil eraser. The F39 resin behaves a little bit differently than most other 3D printing resins. You can see it's got almost a little bit of bounce back when you pour it, and it's really thick. It's got the consistency of Elmer's glue. This really helps set the stage for this material and immediately identifies it as unique from most other thermoset resins. Most thermoset resins tend to be very hard but very brittle, so things like little fine features can snap off of a model easily because there isn't a whole lot of mechanical toughness. They kind of lack the ability to bend. So seeing the build platform lower into the vat and seeing the F39 material slowly cover the top is an indication that this is going to be a unique experience. For a first test print, I used this 3D scan of my face that I created using the front-facing LiDAR scanner on my iPhone 11. Typically when 3D printing with resin, you want to avoid large, thick cross-sections, so any large models like this you want to hollow out before printing. This complements the F39 flexible resin because in addition to the relatively low shore hardness, it also makes a model that can be deformed easily because it's hollow on the inside. Because the F39 resin is a little bit thicker than most other resins, I gave it some extra time on the Lumars to drip dry and also scraped off as much as I could from the build plate. This resin's also a little bit expensive, so I wanted to make sure I was reclaiming as much of it as I could. One of the first things I noticed when I looked at the model was the support structures actually looked like they were sagging a little bit, and you can see they're not perfectly straight. They had a lot of flexibility to them, so they didn't really feel like support structures at all. They just kind of felt like little appendages that were hanging off of the model. They're pretty wobbly, and I wasn't sure how easily I'd be able to remove them. The raft of the model was also surprisingly difficult to remove. I guess in my head, I was expecting a rubber-like resin to behave like a piece of rubber, so I figured that I'd be able to easily remove it from the base, but just like any other resin, when it cured, it really attached on. This is good because it means the print didn't fail, but it's also bad because it means it requires a lot of force to remove. After I removed the model from the platform, I just peeled the support structure right off. It didn't give a lot of resistance, but it is flexible, so it tends to stretch a little bit before it tears off. This means it doesn't always tear off at the model, so you can be left with little nubs of material on the actual model itself. Once the model had been washed and cured, I got right into testing out the overall flexibility, and I was a little bit surprised. It felt more like a vinyl material than a rubber, and it had a really slow rebound, so this model was 3mm thick, but still, even after compressing the sides, it took a little while for it to fully expand back to its original shape. This was a little bit firmer than I was expecting, but it's still very, very soft, especially when compared to a standard thermoset resin. After submerging the model in hot water, the overall level of flexibility and rebound speed was really increased, so the model itself becomes extremely stretchy when it's placed in hot water, to the point where you can pretty much squish it flat and it rebounds pretty quickly. I've seen flexible resin used to make lattice structures in the past, so I wanted to give it a shot. A lattice structure like this is ideal for resin 3D printing. It's got very thin cross sections, but it's thick enough to support itself. It was really clear while it was printing that the lattice structure has a lot of flex to it, and the contact with the FEP sheet is pretty strong. You can see as the model's being lifted, it deforms before snapping back into position. It might not seem like this is a really big deal, especially because the model is snapping back into more or less its original position, but when you think about how the resin 3D printing process works, this model is being stretched out thousands of times during the printing process, so you are going to wind up with a model that is dimensionally not quite accurate to the original CAD. The lattice printed okay, but you can see one of the beams didn't connect with the corner, and it got stuck to the FEP sheet, and eventually it looks like it did release, so you can sort of see where the contact should have occurred, but the model was simply fused together. In terms of flexibility, the part is definitely squishy. I would describe it as feeling rubber-like. I think that's an accurate term for it. And you can ball it up, and it has a pretty quick return rate. It does take a second for it to snap back into its original position. This video here is actually sped up 2 times, so you can see it slowly reforms into its original shape. For a thin-walled model like this, placing it in hot water had a really big impact on the overall flexibility of the lattice, and this is especially apparent in the rebound speed. You can see even if you were to crumple this lattice up and just really form it into a tight little ball, it rebounds to its original shape really quickly, especially in contrast with the room temperature model. I'm not entirely sure what the useful application of this effect would be, but I'm sure there is one. Finally, I wanted to see how much detail the F39 resin could capture by printing out a 75mm miniature from Loot Studios. I picked one of these miniatures specifically because it prints out with a lot of support material, something I think that this resin in particular really needs in order to succeed. The printed support structure tends to feel a little bit noodly, so printing support in dense clusters as opposed to long single strands seems like the best approach for success. As you can imagine, it was a pretty tense print, and you can see the support structure had a lot of wobble to it. During the printing process, when it pulled up and down, you can see a lot of deformation, especially on the more lattice-like parts of the structures. It really stretches during those retract moves, and this is apparent on the printed model. The overall support structure seemed to work okay. The shield unfortunately detached from the model, so that didn't print really well, but generally speaking the support structure did keep the model attached to the build plate. The support material was a little bit more difficult to remove than I originally expected because it's this rubber-like material. On thin individual strands it just separates, but whenever you have a dense cluster of supports it just flexes, so it can be a little bit frustrating to peel away, especially because it tends to break before it makes contact with the model. It's not the end of the world, but you'll probably want to have some tweezers on hand to peel those little pieces off. Once the model had been washed and cured, I was happy to see most of the detail did resolve in the model, but unfortunately having the shield fail during the print was pretty hard to get past. Now this is where you can really see some of the flexibility of this resin. The spear in particular, it's just like a noodle, so this is post-curing and it's still just very flexible. The model itself is flexible too, and it feels like it's made of rubber. So after printing this model, I was left with the question of who is this resin for? At $52 for a half kilogram bottle, it's definitely not for everybody, and it really needs a specific application for it to succeed. I could definitely see this resin being popular for prototyping parts that are typically made with injection molded TPU, like a cell phone case or the grip on a power tool. If you're interested in learning more about this material, I've included a link in the description to Resione's website so you can check it out for yourself. As always, thanks for watching and have fun printing.